So for this example, we will be creating a simulation of a border control situation at an airport. In this case, we're going to be working completely from scratch. The first operation is to configure an initial walkway for boundary conditions and visual appearance. And then we can start to use the simple cut and paste functionality to start to build up the concertina style queuing system that is common for these types of passport and e-gate installations. This example is going to simulate people traffic flowing from 3 aircraft that have landed at the same time, show the flow of people arriving at the queuing system and then flowing through passport control and then heading towards baggage claim. We will look at 2 different situations, one with all kiosks working effectively and then a second situation where a number of kiosks are causing a slight delay, and then assess the impact from those delays on people movement. Once the network geometry has been completely built out, we will then need to change the property values for the walkways at the kiosks themselves. By selecting all of the 7 kiosk walkways, we can apply the private property to them so that only one person at a time can enter a kiosk, and then apply a 30-second delay to simulate the machine reader process. To finish off the movement network, we will need to add people areas. These are entities defining an origin and/or a destination for person trips. We will need a person area at each of the locations where the passengers will emanate from. We'll also need a single person area to define the destination point, which would be the baggage hall. The final step in creating the basic simulation is to enter values for the simulation parameters themselves. In our case, we will enter a simulation term of 20 minutes. We will also add some person properties, which will govern the speed of people movement and their appearance. We will then need to move on to demand. We will set up a simple demand division, which will then let us define the actual demand matrix, where we will specify the amount of people traffic flowing from each aircraft to the baggage hall. So in the demand matrix, we will specify 250 passengers coming from aircraft 1, 137 passengers from aircraft 2, and 125 from aircraft 3, all flowing to the baggage hall, which is people area 4. We can now see the basic simulation in action, in this case running at a multiple of real-time speed. The passengers are flowing from the direction of the 3 aircraft and making their way through the queuing system, stopping at the kiosk before moving on to the baggage hall. To enhance the simulation, we can change the person appearance by loading a range of person types into the simulation, which will then behave in a more realistic manner when viewed closer to real-time speed. So we can see visually that this simulation is creating a short but manageable queue. But we can also view numerical results from the simulation that also react in real time. We can obtain journey data for individuals as well as summary data for all the passengers, including arrival and departure times, speed and distance travelled, and a completed journey count over time. If necessary, we can enhance the simulation further by connecting to other systems such as 3ds Max to generate models to supplement the simulation environment. Now that we have the first simulation running, we can make changes to the simulation parameters to identify what the impact might be if a proportion of the passengers were delayed by an additional 30 seconds due to machine reader issues. To make the adjustment, we just select the walkways in their kiosk positions that we want to edit and adjust the timing delay to 60 seconds. We can see that even with a small additional delay of 30 seconds on only 3 of the kiosks, the queue of people starts to build up and will have a detrimental effect on the passenger experience through passport control at this point. In fact, it is possible to track an individual's experience through the simulation, making not only a visual assessment of the experience, but also view real-time journey data throughout the process. So we can now see how with mobility simulation, we can very quickly create people movement networks, not just for airports, but for any situation where we need to analyze people traffic, and create the necessary simulations to assess the impact the environment, design changes, or decisions may have on people movement.